Okay, so today we're doing lesson 7, and so this is like the second to last lesson before the test, or review week technically, and then the test, but we're starting to wind down, and so it's good to know these topics. Yeah, we're doing sorting methods today. So first, there's some like inefficient sorts, which means that they're just not as, it takes a lot longer of a time than some other kind of sorts that we have, and yeah, it's good to know these though, just because like they're relatively easier to program than some of the other sorts, but you know, you don't want to use them like a lot for larger sets of data. Yeah, sometimes you would want to sort through an array, list, or collection, just like sort them into like increasing or decreasing order. And so you're just learning sorts to be able to learn how to do that. First sort that we're going to learn about is something called bubble sort. Essentially, it takes the original array and switches 2 values at a time until the largest is at the end of the array. And so it compares the first 2 kind of values, sees which one is larger, and then if the larger one is at the beginning, then it swaps the 2, and then it moves on to the next 2 values in the array, compares those 2, sees if it is if they're not in order, then we switch them and continuously switch them until the largest one is at the end of the array. And then it takes the array again, but then minus the largest value that we just sorted, right? So we do 1 less than the max of the array, and then we do the same to that particular array. So it's kind of like continuously sorting, continuously putting the largest at the back of the array that we're considering right now until like everything is sorted. It's kind of like a, yeah, it's called bubble sort. And yeah, continues doing that until the array is sorted. So of course we need to have a drawing, because why not? So yeah, this is kind of like a drawing idea just to like signify like how exactly bubble sort would work. And so you can see up here that we have the ARR equals 3, 1, 4, 0, negative 2. What happens here is again that we first consider the first 2 numbers, right? 3 and 1, they're not in order, right? Like if we're trying to sort to increasing order, 3 and 1 are not in the right order, right? Because 1 needs to be at the very beginning. So what happens is that bubble sort looks at these 2 numbers and says, okay, it's not in order. So we swap it so that it's now 1 and then 3. Now that that's sorted, we then look at the next 2. So we consider 3 and 4 now, right? But then we see that 3 and 4 are also still in order, right? 3 and 4, like they're in order, so we don't need to consider it. So what happens is that we automatically move on to the 4 and 0 next. 4 and 0 is not in order, so what happens is that we go here. 1 and 3 are still the same because they're in order and we don't need to switch them again. We swap the 0 and the 4 so that it is in order now. Then we consider the 4 and the negative 2 now. And again, like it's not in order because negative 2 is not supposed to be there. So again, we swap the 2 and we get negative 2 and 4, and the rest are still the same. So now what you see is that we reached the end of the array for that particular round. And now 4, which is the largest of the array, is now at the very back. And so this completes like one iteration, one iteration of the bubble sort. But now because you can see that the rest are still not sorted yet, we still have to go through the rest. And so what happens then is I just put a line here signifying that we don't consider the 4 anymore for sorting because it's already sorted. So now we're only considering the bottom 4 elements. And again, we continue doing this. So what happens is that we go back here, we see 1 and 3. Okay, well that's still sorted. But then we see that 0 and 3 are not sorted. So we swap those 2, 1, 0, and the 3. The negative 2 is still there. And of course, we're not considering the 4. And then we kind of just go through this again because we just finished comparing 0 and 3. We then compare 3 and negative 2. And so they're not in order, so we swap them. So then is 1, 0, negative 2, and then 3. But then again, because the largest value has reached the end of the array, so-called, and by end of the array, I mean like this line right here. And so once it reached there, and we see that the largest value is now at the end of that particular line, Then we shift this line up forward so that it's like not considering the 3 and the 4 because those two are already sorted. And then again, you can see like we're going back up here and going back up here to finish the sort. We look at these two values again because we're going back to the beginning and we're comparing the two values. We swap the two values so that it's now 0, 1, -2, and not considering the 3 and 4. And then we go to 1 and -2 now because we just finished comparing 1 and 0. We compare 1 and -2 when they're not in order. So we swap those two to become 0, -2, 1, 3, 4. But again, because the largest value is at the end of the array, so like at the beginning of the stick, then we just shift the line again so that it's not considering 1, 3, or 4 anymore because we already sorted them. And then lastly, we just switch the -2 and the 0 because they're not in order. And then we got a sorted array. Woohoo. Yeah, that's kind of how bubble sort works. You can see that there's like a lot of comparisons that need to happen before then, which is part of a reason why it's an inefficient sort, because like it takes so long to get there to the end. But yeah, it's one of the inefficient sorts, and you don't have to worry about this part. You'll see it in a second. Okie dokie. So, of course, it's a coding course, so we have to use some code, of course. So, yeah, I have the coding examples for bubble sort, and I'll zoom in. All right, so just to kind of quickly explain it, or detailedly explain it. For this particular one, we're just going to ignore the top part for now because that's where we run the code, so we don't need to worry about that right now. But I created a static method for this, and what I did was I kind of just had a bubble sort, and then we passed in an integer array for comparing integers. We set a pass variable, and this we'll see later on here. But essentially, this pass variable keeps track of how many values we have already sorted and don't need to consider anymore. This Boolean exchanges value is essentially saying like, okay, you can see here that later on we set it to true, but it's essentially saying as long as we still have elements left to consider, then we should like continue. Yeah, in the beginning we set it to false. So in this structure right here, I didn't really talk about before, but it's another type of loop, and it's called a do while loop. Essentially what it's saying is, okay, first at least do one iteration of whatever is inside of this do part, and then we consider the while part. So then we check the condition to see if we want to go again with a loop. But essentially it's like a while loop, but instead of first comparing the conditions, it does one iteration of the loop first, and then it compares. So now it's comparing the conditions always at the end of the loop. So yeah, otherwise like it works the same. But essentially, yeah, so we go here. We always set exchanges equals to false first because we want to make sure that we don't, after we set it to true here, that we don't always have the same true value, because that would end up in like a infinite array loop. And so we don't want that. So what we do then is we say exchanges equals false because we don't know if we still have any more values to run. We have a for loop now, and now we're saying int I equals 0 because we're trying to start at the beginning of the array. We're saying as long as I is less than arr.length minus pass. This might be confusing, but what it's saying is as long as I is less than the max array length minus the number of values that we already sorted. So again, like I was saying, the pass variable keeps track of which values we have already sorted, like how many values we've already sorted. And so at the beginning, we're saying -1, right? Because pass is initially 1. So when pass is 1, that essentially just means we're still sorting through the whole array. So that doesn't really matter much. But you can see later that we're incrementing pass by 1 every single time later on. So what happens is that as we finish sorting one particular value to the end of the array, then we're going to increase pass. And that means we're going to consider less and less values as we continue sorting. We increment I by 1 because we want to make sure we check every single value. And this part is kind of like where we're comparing things. What you can see here is we're saying, okay, well, if the current value is greater than the value that is after it, essentially meaning if the value that we're currently looking at is out of place with the value above it. So like if it's greater than the one above it, which would be out of place, then we have this code. And what is important to know about this code is like it's the standard swapping code. What I mean is that like whenever you want to swap two values within an array, you would essentially always use this, right? So what I'm saying is int temp equals ARRI. That just kind of keeps a temporary variable to make sure we don't lose the value in when we're trying to swap the values. We're saying ARRI is now equal to the value that is above it. And then we're saying ARRI plus 1 is now equal to the temp value, which again is the ARRI value. So again, this is like the best way to swap two values because otherwise, if we say ARRI equals ARRI plus 1, and then ARRI plus 1 equals ARRI, that's just going to make it so that the two variables have the same exact value. Because when we're saying this, when we have this line, we're like ultimately changing the ARRI value to the ARRI plus 1 value, right? And so that means that the original ARRI value is like lost forever because of the fact that we changed it. So that's important to note about that. Sorry. And so what we need to do is have a temp variable already to keep the original ARRI value so that we can set it, the other variable, to the original ARRI value. Yeah, it's essentially just swapping code. So whenever you see this, you should be like, oh, it's swapping, right? Because it's always the same exact code pretty much. You always have to have a temp variable and you always have to like do this kind of swapperoo. But yeah, essentially this if statement here is just saying, okay, if the two values are out of place, then we should swap the two values. And so this is again like how we're swapping the bubbles. After this for loop, and I noticed the indentation is kind of weird. There you go. Oh wait, no. Whoops. Some indentations are weird. You can see over here that after the if statement, we are setting exchanges equal to true. And it's essentially just saying, okay, well, we already swapped the two values. The fact that we are going into this for loop in the first place is saying that we still have values to compare, right? And so by setting exchanges equals to true, then that just makes sure that we still go back into another iteration of this loop so that we can compare the other values. Because after we swap the value or like check the value, then we need to go back over again to make sure that everything else is still sorted. But yeah, this loop continues going until it reaches the end of its maximum endpoint. So like after I went through everything that it needs to be checked again, then we're incrementing past by 1, which again means that, okay, well, we already found the largest value and moved it to the end of the array. Well, then we're incrementing it by 1 so that the pass by 1 so that we don't compare it again. And so that's what happens here. This ends the do while loop. And what happens is that now we compare, right? Now we compare to see whether or not we need to go on for another iteration of the do while loop. And in this case, it's saying like while there's still something left to be compared, which is signified by the exchanges variable, then we go for another iteration of the loop. So then we go back here. We use a new pass variable because, like, again, we incremented it by 1 here. We use a new pass variable to go back here. We started it all over again to make sure that we're swapping everything to the back of the array that needs to be. And yeah, again, because the pass variable increments every single time, at one point, pass is going to be equal to like ARR.length. So what happens then is because ARR.length minus pass, which is ARR.length, that equals 0, which means that I is not less than equal to 0 anymore. So that means it automatically fails this for loop. It never initializes exchanges to true ever. And then that means that like when we reach the while exchanges here, then it's automatically going to evaluate to false, and we're just going to quit out of the loop, which means we're done with the bubble sort. And then over here, it's kind of just test code, but essentially I just had an integer array. I passed it into the bubble sort, and I checked it to see if it was ordered or not at the end by printing out the whole array. All right, any questions? How do you feel? Scale of 1 to 10, how much does this make sense to you? Okay, what does okay mean? Does it mean 0 or does it mean like 5? Okay. Well, let me know, because again, just warning you, you might be tested on the code, so be sure you know it. Right, anyways, that is bubble sort. Today we're going to learn 3 inefficient sorts. Yeah. So next one we're learning is insertion sort. And what this means is it starts from the second element of the array and compares it with the first element in the array. If it is out of order, then insertion sort will just insert the second element where the first element was. So it's kind of similar to the bubble sort at the beginning, but it's not. And essentially, insertion sort will just continuously move up the array to the third element, to the fourth element, etc., and continuously move down the array towards the first element, comparing each one that it reaches. Okay, so like with the element that we are currently working on, so let's say we're trying to find out where the third element is supposed to go, right? It'll first compare the third element with the second element, see if it's out of order. If it is out of order, then the third element will then compare with the first element. If the first element is also, the third element is also out of place there, then it automatically puts the third element at the very beginning. And I know that's kind of confusing, but like I have a diagram, also code later. But yeah, it's essentially just looking at the element we're currently working on and then comparing each one below that to see where it should go in the ordering. And so it continues doing that. It goes on for the current element once we sorted that to the next one we're supposed to be looking at, and then finds the place where the element is supposed to go, and then we essentially insert the element there where it's supposed to go. But yeah, diagram. Okay, you can see it's a lot shorter than the bubble sort array. But yeah, essentially we have the beginning array 3140 -2. Again, what happens is we start at the second element, sorry. We look at that, we see, okay, well, it's not in order right now because 3 is not supposed to be there compared to 1. So we insert 1 at the beginning and push everything else back. So now it's this array. But then we move up to the third element in the array. So we look at 4. Okay, well, 4 is in place, right? Like we can see, okay, we compare 4 and 3. 4 is in place like that. We also compare 4 and 1. Well, it's also supposed to be there, right? Compared to the 1. So then that means that the 4 is in the correct place where it is, and we don't need to move it anymore. Okay. I don't know if that makes sense or not, but essentially it's saying, okay, well, 3 and 4, that's in the correct order. 1 and 4, that's also in the correct order because of the fact that 1 is less than 4 and 3 is also less than 4. So that's why 4 is supposed to be there. Because of the fact that 4 is already in place, we're just going to compare the next one, 0. Well, 4 and 0 is not in place, right? So, okay, we then compare 3 and 0. It's still not in place, so that's still not the correct place. We're supposed to put 0. And then we'll compare 1 and 0. Well, it's still not exactly supposed to be there, right? So then we automatically know we should be placing the 0 at the very beginning of the array because it's the smallest element now. So that's what we do here. We push 0 at the beginning and push everything else back. And now after we compare the first 4 elements, we compare the last one. And you can see again, -2, well, it's not in place with 4. It's not in place compared to 3. It's not in place compared to 1. It's not in place compared to 0. So we have to put it to the very beginning again. We put -2 at the beginning and then we push everything else back. So yeah, it's essentially a process of looking at the element and comparing it with every single element below that. And then determining where the element's supposed to go and then placing the element there. All right, of course, again, we have to have code. Right, again, let's ignore the top part for now because that's not the important part. Okay, so very similar to the bubble sort. Again, we're having a static method and then we're not returning anything. In search and sort, and passing in a an array of integer data types. From here, we're looking at this. Firstly, again, we have a for loop because that's always important. We start at integer I = 1. We're saying as long as I is less than array.length, then we continue and we increment I by 1. So what this is saying is that we're starting at 1, which is the second element in the array. And then we make sure we go through every other element after that and compare it with the ones before it so that we can find the correct place. So this is essentially the same. We're going to go through all of the elements of the array and make sure we check them to see if it's in the correct place. We keep track of what the value of the array is at that particular point, and we keep track of the index because it's going to change. Now, what happens here is that we're saying while index is greater than 0, so like while the index that we're looking at is not less than 0 or below, then we're going to go on. But also, we need to make sure, and by the way, like again, and means both sides of the expression has to be equal to true for this total expression to be equal to true. Then we're also saying as long as value, so this particular value that we're keeping track of and that we're looking at right now, is less than ARR index -1. So as long as it's less than the element below it, then we continue going on. So as long as both of these conditions are true, then we go on. And what this value less than ARR index -1 is it saying as long as those these two values, the one we're currently looking at and the one below it, as long as they're not they're out of order, then we're continuously swapping them, right? Or like looking at where it's supposed to go. So in this case, it's saying like, okay, if value is less than ARR index -1, then that means that the element below it is greater than the current value, which is out of place, right? So that's why we continue going. This particular while loop is supposed to be swapping those two. So then we look at ARR index equals ARR index -1. So what happens here is that we're saying, okay, we'll just continuously move, make it so that the current value that we're looking at, the current place, make it so that the element below it is now that particular value. So we're essentially, with this piece of code right here, we are essentially moving every single value up one place so that we're moving it to the right. Every single time that they're not in place, the elements are not in place, then we continuously move the value that we're looking at back one place. Yeah. And so that essentially just continuously moves the elements backwards until we find the place where the element we're looking at is supposed to go. And this makes sure that we have space to place the element whenever we find the right place it's supposed to go to. And we decrease index minus by 1 every single time, because again, like I was saying before, insertion sort is supposed to be comparing the current value we're looking at to every single value below that. So this index minus is the is how we're comparing the current value we're looking at to the ones below it. And yeah, this essentially just continues moving on until either index is equal to 0 or below, which it shouldn't be below, but as long as it's equal to 0, if it's 0, then this will evaluate to false, which signifies that the element should be placed at the very beginning. Or if we find the correct place. So if we find that the element below it is less than the value we're looking at, then we know it's supposed to be in the correct place. And so we exit out of the loop. So again, this loop's purpose is to find the correct place where we're supposed to put the element. This last statement is setting the AR index, which is the index that we found that the element's supposed to be at, equal to the value of that particular element that we're trying to find a place for. And so again, we reach the end of the loop and then we continue going on. So again, because it increments every single time, we're comparing every single value, we're finding the correct place of it, and then we are inserting it. So we continue doing that until we reach the end of the array. And then we're done. All right, that was a lot. Any questions? Scale of 1 to 10. Okay, then. Again, let me know. Yeah, selection sort. So this picks the smallest or the biggest number, depending on how you coded it, and switches it with the first element. It then finds the next smallest number and swaps it with the second element. And it continues until the array is sorted. So this one's also kind of swapping. And it's also kind of like insertion in the fact that you're trying to find the correct value. But essentially, it continues swapping the value that we're looking at, the smallest number, with the beginning or like whatever value you're trying to find a place for. Continues doing that until the array is sorted. And so diagram. I know I kind of went quickly through that, but let me know if you need any going over again. So yeah, we have the beginning array again, 301, 40, -2. We look through here, we find what is the smallest value right now, really, right? And we see that, okay, well, the smallest value right now is -2. So we swap that with the very first element. So now you can see we have -2, 140, but then now we see that the first element's now where the -2 was. And again, we find the smallest value now that is not -2. We look at 1403. We see that 0 is the next smallest element. And then we swap it with the second element in the array. So now it's 204. Now the 1, which was previously the second element, is now where the 0 was. And then we have 3 still. And looking at here, right, the elements between 4, 1, 3, which one's the smallest, right? 1 is the smallest out of those 3 elements. And therefore we swap it with the 4 because that's the next place it's supposed to go. So -2, 0, 1, 4, 3. And lastly, between 4 and 3, what is the smallest one? Then it's 3, right? So then we just swap the 2. And now we have a sorted array. So yeah, it's constantly, this particular sort is about finding the smallest element and then swapping it to the front. Next smallest element, swapping it to the second element's place. Next smallest element, and then swapping it to the third element's place, and so on and so forth. So it's about finding the smallest one and placing it where it's supposed to go. And again, have a code for it. All right, go back here. Again, ignore the top. So over here, we are starting at 0, and we're saying go to array.length -1. And we're not comparing it to, we're limiting the array like that because we don't need to compare the last element again. Like by that time, we already know it's going to be sorted, because if we only have 2 elements left to compare and we swap the 2, then like we already know that it's sorted, so we don't need to compare that again. But yeah, first we're trying to find a min index. So this is like essentially where we're keeping track of which element within the array is the smallest one, right? So we start off with just the I, like whichever index we start at here, we start at that particular index. We're saying for int j equals I, because we want to start at that point and only compare the ones after that to see if it's the smallest one. J is less than AR.length because we don't want to go over the array length, and j increments by 1. Essentially, this code is saying, okay, if the current value we're looking at for the j value, if it is less than the ARR min index, which means like if we found the next, the smallest element, we found that the current element we're looking at is smaller than the one that we were that was being kept track of in the min index, then that is the smallest element, right, that we know of right now. So we need to set the min index now to equal to j index, because again, the min index is trying to keep track of what index has the smallest element in the constraints we're looking at. So this line of code is essentially continuously comparing until we find the smallest element in that particular boundary. So yeah, this for loop's doing that. Now that we, after all of this, this would give out, come out with the correct min index, the index that has the smallest value in the array. Then we know that we can swap it, right? So what happens is that, again, if you look at this code, right, you should be like, okay, it's swapping, right? Because again, we have the temp variable, and then we're swapping it now again. So therefore, what we're saying is int temp equals ARI to keep track of the original value. We're changing the ARI value, the one that we're currently looking at, to the element that is the smallest one that we found, right? The smallest value of the element. And then we're swapping the place where the smallest element was kept to the original ARI value. And so again, this like achieves the fact that we find the smallest element within the array, and then we swap it with the place that we're looking at. And so that continuously finds the smallest element in the boundaries that we're looking at and places it where it's supposed to go. Yeah, that is the end of that particular array. Scale of 1 to 10. How does this feel? Any thoughts? Do you have any questions? Okay, if you're sure. Yeah, any questions? What do you mean, what happened to lesson 6? I mean, like we already did lesson 6, right? Oh, well, that's probably because I didn't put it there. Forgot to put the links there. Yeah, I'll put it later, but yeah. I will put it there. And I'll also put this lesson slides there. All right, just gonna finish off this lesson. But yeah, there's a visual tool just like we had one for last lesson, and it will be like the kind of visualization of the sorting methods we learned today. So yeah, let's start off with bubble sort. So what this does, right, is it can help sort. So looking at this array, let's say, of different values, it's going to sort it. So let's see. Sort, it's going to start off slower. You know, if we can actually, anyways, there's some code over here if you want to look at it. But see, it's swapping values that it sees that are not in order. Continues going through. Continues swapping until it finds a value that is not in order, or in order. It sees 47 and 50 are in order, so it doesn't move them. And you can see now that the 50 is at the very end, and that's like the largest value, so we don't need to compare it again. And again, we continue going through. Swapping it. And I'll go a bit faster just to get through this. Yeah, again, it's continuously swapping them if it finds it's out of place. And it keeps does not compare any of the last values anymore, the last ones that we already sorted. Yeah, you can kind of see the pattern now. Yeah, and then so now you can see that everything is sorted like that. So again, if it compares two values and it's out of place, then it swaps it and moves on to the next pair. It continues swapping it until the largest value is the very end of the array. It ignores that value, and then it does the same for all of the rest of them. Continues doing that until everything's sorted. Now you can see up here there's also selection sort. So let's do insertion sort first, just for sake of ordering. Gonna start slow. Compares the 44 with a 3, and it's in order, so we don't need to worry about it. Compares the 38 with the 44, finds that it's out of place, so it finds the correct place to go, inserts it there. Compares the 44, 38, and we find that that's the place where it's supposed to go after comparing. Compares 47. Oh, well, it's in place, right? So we don't move it. Continues moving down to find the correct place, depending on what the comparison is. Continues comparing. And I'll speed it up a bit. And it's sorted. Yeah, but essentially it continues swapping it until it finds the correct place by comparing it with every single value below it. And it finds the correct place and places it in. So now you have sorted array. And lastly, just quickly, selection sort. Checks to find the smallest one, and the red value, the red number indicates that it's the smallest number. And it goes through every single other element in the array to find the smallest one. Oh, well, now 2 is the smallest value. So now we highlight 2 as the smallest value. Continues comparing the rest of the array. And now we swap those two because, again, we want to put the smallest element at the very beginning of the array. This continues finding the smallest element that is in the rest of the array, not including 2. Can speed it up a bit. 3 is the smallest value. Now we swap those. Continue finding the smallest element by comparing everything with the current smallest one. Gonna go faster. Again, finding the smallest value and swapping them. And we're sorted. The last one's a bit quick, but essentially, again, we're trying to find the smallest element by going through every single thing other than to find the smallest value in the rest of the array. And then once we find it, then we're swapping it with the first one. And continuously doing that until we have everything finished. All right, there's some other sorts here, but like we're either going to learn them later or we're not going to learn them later. So don't need to worry about that. Also do have to note, I did not find this site. It is my teacher who found it. So credit does not go to me for finding it, but it is a good thing to go for. And also the creator is these people. So I did not create this. All right. But yeah, that concludes the lesson.